Hello everyone, welcome back to the channel. In today's video, we are going to learn about JDBC, which stands for Java Database Connectivity. Now, if you are completely new to databases or Java database programming, don't worry at all. This video is designed for absolute beginners. By the end of this lesson, you'll understand what JDBC is, why it matters, and how Java applications communicate with databases in the real world. So, let's get started. First of all, what exactly is JDBC? It is JDBC stands for Java Database Connectivity. It is basically a standard API provided by Java that allows Java applications to connect to relational databases. Now, that definition may sound technical, so let's simplify it. Imagine your Java program and your database are two people speaking different languages. Here is one person speaking English, and here is another person speaking Spanish. JDBC acts like a translator sitting between them. JDBC acts like a translator sitting between them. Your Java application sends requests through JDBC and JDBC helps the database understand those requests. So without JDBC, your Java application would not know how to communicate with the database properly. And databases are everywhere: banking systems, shopping websites, hospital software, student management systems. Almost every modern application stores and retrieves data from a database. So JDBC becomes extremely important in backend development. Now let's understand why JDBC matters so much. The first reason is vendor independence. Different organizations use different databases. Some use MySQL, some use Oracle, some use PostgreSQL, and others may use SQL Server. JDBC provides a standardized way to interact with all of them. That means your Java code remains mostly the same even if the database changes. You only need the correct database driver. This makes applications more portable and easier to maintain. Now think of it like a universal charging cable instead of needing a completely different charger for every device. JDBC creates that common standard for Java database communication. This is one of the biggest reasons why JDBC became so widely used. Now let's talk about the core JDBC components. The first one is connection. A connection object establishes a session between the Java application and the database server. In simple words, this is how Java enters the database world. Second is statement. A statement object is used to execute SQL queries and commands. For example, select, insert, update, or delete queries. Third is prepared statement. This is a more advanced and secure version of statement. It improves both performance and security. And finally, we have ResultSet. When we run in a query and get data back from the database, that data is stored inside a result object. So remember this tiny formula. Connection connects, statement sends SQL, prepared statements improves safety, results set stores return data. If you understand these four components, you already understand the basic architecture of JDBC. Now, this slide is extremely important. PreparedStatement is one of the most commonly used JDBC features in a real-world application. Why? Because it provides both security and performance benefits. Let's start with security. PreparedStatement helps prevent something called SQL injection. SQL injection is a dangerous attack where malicious users try to manipulate SQL queries through input fields. PreparedStatement treats user input as data instead of executable SQL code. That makes applications much safer. Now let's talk about performance. Prepared statements can also be reused efficiently. The database can prepare the query once and execute it in multiple times with different values. That reduces parsing overhead and improves performance. For example, imagine searching customers by ID again and again instead of rebuilding the query every time. Prepared statement allows efficient reuse. So in modern Java applications, prepared statement is usually preferred over normal statement objects. Now let's move to batch processing. Imagine you need to insert 1,000 records into a database. If your application sends them one by one, it creates many network trips between the Java application and a database server. That slows things down. Batch processing solves this problem. Using methods like add batch and execute batch, multiple SQL operations can be grouped together and sent in one request. This dramatically improves performance. A real-world example would be an inventory management system updating hundreds of products at the end of the day. Instead of updating every product individually, the system processes them as a batch. Less communication, less overhead, better performance. That's the power of batch processing. Now let's talk about transactions. A transaction is a group of operations treated as a single unit. In JDBC, the default behavior is called auto-commit mode. That means every SQL statement is automatically saved immediately after execution. But in many real-world situations, multiple operations must succeed together. This is where transaction control becomes important. The basic flow is begin the transaction, execute multiple SQL operations. If everything succeeds, commit the transaction. If something fails, roll back the transaction. Rollback means undoing all the changes made during that transaction. This prevents inconsistent data from entering the database. Now let's understand transactions using a real-world e-commerce example. Suppose a customer buys a product online. The system may need to deduct inventory stock, create an order record, store payment details, and update customer history. Now imagine the payment succeeds, but inventory update fails. Without transactions, half the data would be saved and half would fail. That creates corrupted or inconsistent records. Transactions solve this problem. If any step fails, rollback restores everything to the previous state. It's almost like a time machine for database operations. Either everything succeeds together or nothing is applied at all. And that is extremely important for systems involving money, banking, shopping, and sensitive data. Now let's look at some important JDBC best practices. First, always prioritize security. Use prepared statement and parameterized queries whenever possible. Second, design transactions carefully. Related operations should commit or roll back together. Third, batch processing for repetitive operations involving large numbers of data. Fourth, handle exception properly. Always close database resources correctly so the database does not remain locked or unstable. And fifth, validate data before inserting or updating it. Professional applications are not just about making code work. They are about making code reliable, secure, and maintainable. Now let's summarize the major benefits of JDBC. JDBC improves security through prepared statement and parameterized queries. It improves performance through reusable statements and batch processing. It improves reliability through transaction control and rollback mechanisms. And finally, it involves portability because the same Java application can work with multiple database systems. So JDBC is much more than just connecting Java to a database. It creates a structured, secure, and efficient way for applications to manage data. So before ending this video, here's a question for you. How do prepared statements and transactions work together to make CRUD operations safer and more reliable in Java applications? Try answering this in the comments section. If you understood today's lesson, then you already have a strong foundation in JDBC. In future videos, we can move into practical coding examples where we actually connect Java to a database and perform real CRUD operations step by step. If you enjoyed this video, make sure to like, subscribe, and share it with others learning Java. Thanks for watching, and I'll see you in the next video.